Good morning. Today in this video we're going to be talking about Math 3 Unit 4 Assignment 4.5. And Assignment 4.5 is focused on solving equations that have radicals or fractional exponents. And so it's a nice continuation of what we've been building to in this chapter. I think that, let me change out of an eraser. I'm going to change my writing tool. We'll go with blue. That looks wonderful. I think that this portion of the assignment would make good lecture notes and classwork with the remainder as homework. But if you're writing your own lecture notes, then I want to encourage you that this piece right here, numbers 1 and 2, start with students needing to isolate the root before they square both sides. And that's a good place to begin because that's a common mistake for students to not isolate before they square both sides. And so if you are writing your own notes, make sure you include isolating right at the beginning so they get the hang of that. This next piece is one of the two main things I wanted to talk about in this section because it is unnecessarily complex. And to help you understand a simplified version of this, and I think your students probably could use a simplified version. This unit has been a little bit difficult for them. To help you understand a simplified version of this that you might be able to give to your students, I want to compare the solving of this problem with one of these two. And so we'll begin with this problem. I'm going to copy it over here where I have more space. This is problem 2, or example 2. There's a video of this problem being solved in the PowerPoint notes that you can use. And so it says this, 2x plus 3 to the 2/3 equals 8. You can do this short or long way, but in either case, let's begin by isolating the piece that's to a fractional exponent by dividing by 2. And so I would have this spot. Here, we can think of this this exponent as one exponent to get rid of or as two separate problems to get rid of. If students wrote this in radical form, they would have the cube root of x plus 3 and then that quantity squared. And so there's two different pieces to get rid of. We need to get rid of the cube root and we need to get rid of the squared. And so one way we can do it is in steps like that. In here, they're also mentioning that you could raise to the reciprocal power. And I think that that is a little bit shorter, but just for you to understand why they're saying what they're saying, I'm going to do this in pieces. And so we can think of this as the cube root of x plus 3 squared. And so first, to get rid of that cube root, I would cube both sides. Raising something to the 3rd power does not cause any concerns about sign. The 3rd power isn't going to disguise anything. But now the second thing I need to get rid of is that squared, and I will do that by square rooting both sides. And, pardon me, I keep hitting the board. As I square root each side, I need to remember that even roots will always yield positive answers. And so the square root of 64 is 8. And the square root of x plus 3 squared will be x plus 3. And I just need to make sure that that is positive by putting on an absolute value. So then, since we're solving, a lot of you, instead of showing it like this, will just show this version of that. That's fine. This is another version that this could be positive or negative 8 when we square root, because that's the next step in solving an absolute value, that x plus 3 might equal 8 or x plus 3 might equal negative 8. So whichever way you're choosing to explain this is fine. Both are 100% correct. And then as we solve each case, we're going to get x equals 5 and x equals negative 11. If we go back to check these cases, because since we've square rooted both sides, we might have an extraneous solution. As we check each case, I believe you find that both cases in fact do work. Okay. The alternate way that you could solve this, I'm going to change colors just to contrast my work here. So the alternate way that you might solve this is taking from this spot right here I could tell the students to raise to the 3/2 power. Might be nice to talk about which way they prefer and why. Some students might like this way this first way because they have a hang of each step. They truly understand what's going on, and in this step they don't really remember the meaning of what's going on. But if we multiply these exponents, we get 1, and so I would have x plus 3 to the 1, and then I would have the square root of 4 to the 3rd. And as we solve this, notice that the square root of 4 is 2, 2 to the 3rd is 8, and I only have 8, not plus or minus 8. Okay. So what this little section right here is telling us is that if x is raised to a fraction power and you raise each side to the reciprocal power, if either m nor n, either the numerator or the denominator, is even, then throw some absolute values on there. So in this case, the numerator was even, and so we throw absolute values on, is what they're saying. And the way it shows, if you watch the video, it shows that this came out to x plus 3 to the 6/6. Since you're taking an even root, that 6th root, you should put absolute values on. Okay. That would work. Then that would cause me to have two cases, x plus 3 equals 8 or x plus 3 equals -8, and I would go ahead and solve. Okay. This does take a little bit of extra thinking. This is natural. We've been already saying anytime we square root or add an even root, we need to put absolute values to make sure that the thing that we get out is positive out of an even root. And so this one you really have to be careful and think of that. But what I would say to you is I disagree with if either of those is even, then we need to do that. I would tell you that only if you are putting an even root on. So in other words, if this numerator was even here, so when we do the reciprocal, we put a denominator that's even, then we've put an even root. That needs absolute values. If you go to the trouble of putting on absolute values every time you do a reciprocal power, and either of them are even, then what you'll find is always the second case doesn't work because a cube root didn't really need those absolute values. So for instance, in a problem like number 3, I'm going to divide by this 3 and have x minus 2 to the 3/4 equals 8. Now, if I want to do this with reciprocal power, I would be raising to the 4/3 power, a cube root. If I wanted to do this 2 steps at a time, I would be raising to the 4 cube rooting. So I'd be cube rooting each side and then raising to the 4th power. The cube root wouldn't make me add absolute values because it's an odd root. And the 4th power, any power you don't add absolute values for. And so on this one, if I take it 2 steps at a time, I have the, I'm going to choose to undo the cubing first because I think that will keep my numbers smaller. So I'm going to choose to take x minus 2, the 4th root of x minus 2 to the 3rd. You could undo them in either order. And if I'm going to do one at a time, I would rather cube root each side and keep a nice small number. So if I cube root each side, then I will have the 4th root of x minus 2 is the cube root of 8, also known as 2. When you do a cube root on both sides, you're not going to need absolute values. And then I would take each thing to the 4th power. And again, this doesn't require any special absolute values or signs to worry about. We can always raise something to a power, and we'll be able to solve this without any plus or minus situation. Again, because we were cube rooting and then raising to the 4th power. Here, we were square rooting, and it's an even root that causes the trouble. So what you might encourage your kids to do is they can take the shortcut of raising to the reciprocal power, but if when they raise to the reciprocal power they have an even on the bottom, that means they're adding an even root, and they'll need to think about the plus or minus situation when they do that even root. Okay, so that That would be what I would tell you. If you would like to have them put absolute values every single time, you can. It will just create more work checking, so that it makes it a little bit longer problem. So it's your choice. They don't have, the answers will come out the same either way. It's just one way is a little bit longer than the other. And so it's your choice how you would like to have them do that. Besides that one bizarre spot right there, this is pretty traditional. Right here, you're running into the problem that when you square both sides, so I have square root of negative 3x minus 5 squared equals x plus 3 squared. I need to make sure that the students realize that this is not x squared plus 9. This is x plus 3 times x plus 3, and multiply that out. On this problem, I know, on this problem, I know I begin to get extraneous solutions that I need to double check back and see whether they work or not. And so anytime you're squaring both sides, that could happen. So that's what's going on there. This one is another one of those. So this would be a good case for you to do one and then them do one together. Maybe start it by rewriting it as a square root, them to do one together. On number 9, that's a very simple problem, but number 10 is probably the hardest of them. This is one of those where you isolate one of the roots, your choice, and then when you go to square both sides, you have quite a large mess because this is a binomial that is going to have to be distributed out. 3 minus root x plus 2 times 3 minus root x plus 2. And this is by far the most challenging problem on the homework assignment. There are some over here that you can pick to discuss like that. Number 33 was one that I picked that would be similar to that, where they would have to square once and then isolate the remaining radical and square a second time, just like 10. So it'd be a good complement problem. Number 31 and number 34 are cases where there is an even on the top of the fractional exponent. So as you solve that, you will have to take an even root to get rid of it, and you'll have a plus or minus case. And so those would be two problems that you would worry about, like in the problem example 2 with the absolute values. Okay. Other than that, I would say to you that 17 and 18 were very nice little discussion questions. They're not very long. I like 17 because it helps kids solidify their thinking. How is solving a square root equation similar to solving an absolute value equation? And so in both cases, students need to get the difficult piece isolated before they begin to take care of it. And so that's just re-emphasizing that thought. Okay, you always get that tricky spot by itself, and then you do whatever you need to do. Square both sides, set up two cases. Other than that, you don't set up two cases normally on a square root problem, only if you are running into absolute values. And so it just kind of gives them a spot to think and organize their thinking about those two situations. And this is a nice quick check of extraneous without making them go through a whole problem. It's a nice quick check of their understanding of the word extraneous. So that's two nice discussion questions you could do when they first came in the next day. You could do at the very end of class. Either way, those would be nice. The other problems that I did not put in the assignment that I really liked were 19 and 20. They continue to have really nice geometry applications throughout this chapter. And if because of the strange holidays and stuff that are appearing right now, you have a day to kill either before or after the test, I could imagine making an assignment up of the different geometry problems similar to a task day, but specifically focusing on geometry application. There's an awful lot of really nice problems that use radicals in geometric situations. And so they would be good things to do if you have a day just before Thanksgiving break that you don't want to start something new, or just after Veterans Day or something like that. All right, I think that's pretty much it. Oh, a couple points here at the end. These incredibly challenging problems. I know that I tried one of these, I think it was 42, and I got to a spot where I needed quadratic formula. That didn't happen to me anywhere up above. And so I would encourage you to work these problems before you chose to assign them. I think they look promising for an honors class. This 44 and 45 ask us to think graphically about solutions, and we have an entire worksheet on that. It was 4.5b. I think most sites have decided to move that to be 4.9 near the end of the chapter as review. Yeah, it works either place, where we'll look at the graph of functions and where they intersect as solutions that we're finding. And so we'll come back to that. If you wanted to have them do one by hand, again, honors group or something, I would say 44 is more doable by hand. This 45 looks like something you would definitely need a graphing utility for. So anyway, with all that said, I wish you the best of luck on this assignment. I think the problems that students will be problems that students have had in your Algebra 2 classes before. And so you probably are well aware of those places. And the only thing that's really weird is this little box, and that I did not see in an Algebra 2 book before. And so I just want you to think about how you want to explain that and then be consistent with that. You might talk in your PLC. It would be nice if at a site students were hearing the same thing if they work together. All right, I wish you the best of luck and have a great day.